Hey there, Nancy from Metal. Welcome to part 2 of our Battleship parody tutorial. If you haven't already done so, you really should watch part 1 first. In this, part 2, Matthias Moll of Mammo World uses eye expressions to create a character rig for the Hypno Precompulator. He makes very realistic movement easy to achieve. So let's begin.
Yeah, hello and welcome to this tutorial. What I'm going to show you today is how to create a nice animation rig for this character here, for the Hypno, such that it is much more convenient to animate. And what we start with is this character already created, but without a rig and already with a position animated. So you can see here in the before part, let me just play it. It is already moving. This is done with keyframes, and the tail here is appearing. But then when it moves, you can see it doesn't move really realistically. Yeah, and this is in particular because this tail is not moving at all here, and also since it's not turning. Yeah, this guy here should really turn while it is moving. And now see here how the final result will look like. And note that all of this animation is now based on exactly the same keyframes with just some expressions applied to it. So you can see here the tail is rotating, and it's not just rotating, but it's also moving really realistically with the animation. Yeah? So this means if you keyframe a movement left-right, the tail will swing as it's doing here automatically. And the first thing that we want to do for this is make the head of the Hypno turn into the direction where it is moving. Yeah. So in my composition, I have here some layers. Maybe let's go over them quickly. So we have some lights and some precoms required. I think all of this we discussed in the first part. So let me just hide all layers that are not so important and only look here at the actual shapeshifter effect on this main layer. And here you have now the position, which is keyframed, as you can see here. And we have this rotation x, y, and z value. And this rotation x and y allows to turn this Hypno here, as you can see, up and down is in this case the x rotation. So let's set this back to 0. And this here is the y rotation. And what we now want to do is to link this rotation to the actual speed of the movement. This means we need to link it to the position, but not to the actual value of the position. So not when the position is, say, 100, the rotation should also be 100, but we want to know when is this position moving. So what is its speed? Therefore, we use a simple link 1DI expression and set the link to value to speed. The result looks as follows. So this is what it looks after application of the I expression. You can see when the Hypno moves, it automatically turns. And this here is how it looks without the I expression. You can see the Hypno only moves, but it doesn't turn when it is moving. To do this, we go in the I expressions tool to the library, and there we choose in the linking bundle the simple link 1D. 1D because it's a 1D property, yeah, not like a 2D position or so. This is because in Shapeshifter, these position x, y, z are separate values. Okay, we said we wanted to link the x rotation, this is this up-down rotation, yeah, to the y position, so movement up-down. Therefore, we select this position here and click here on the link to. And now in the options, we go, as discussed before, not to value, but to speed. If we apply this now to the x rotation, apply, you can see that when the Hypno moves up, yeah, it starts rotating. But you can see here it rotates way too much. Yeah, it rotates a lot of movement, a lot of rotations, over 3 full rotations up. So this is much too much. So we just use the scale here to make it move less. We set it to 2% and reapply. And now you can see that when the Hypno moves, it automatically turns. Maybe this is a bit too less. Make it, say, 6% to make it a bit more visible. And now you can see that when the Hypno moves up, it automatically turns upwards. And now that it stops, it automatically turns back again to 0. in exactly the same way, you can of course also link here the Y rotation to the X position. So I'm not going to show this in detail because it's completely identical, and just choose the scale here appropriately such that according to your speed it moves or turns nicely. And yet another property that we can animate with exactly this expression is the spiral rotation. So spiral rotation. And if you look at the spiral rotation, again, it exists here in X, Y, and Z. And this controls actually the tail. So if we go here to some point where the tail is already there, and we adjust the spiral rotation, so let's set this here, for example, to 5. You can see it turns in the other direction. If we set it to -5, it turns in this direction. Yeah, and here we can turn it up and down with the X coordinate. If we set this to 5, it turns down, and -5 in this case, it turns up. So the idea is again exactly the same. Also for the spiral rotation, just apply a simple link 1D that directly links to the speed of the position. So this means the spiral rotates whenever you move, and the faster you move, the more it rotates. And this then looks as follows. Again, here's a comparison with the original, and this is with the I expression. And you can see that, so let's look at this again in a slow-mo. Here, whereas here, the tail is very stiff and doesn't move at all. Yeah. At the same time, here the tail is curved very much and looks like it acts a bit delayed and is swinging after the movement. Yeah. Once again in real time. So here you have now the nice elastic movement of the tail, whereas here the tail looks rather stiff, or 100% stiff to be accurate. Now to do this, we can basically just copy and modify the expression we've applied to the rotation of the head here. Yeah, so I select the Y rotation, which has here this simple link I expression applied, and click on load. And now I have this I expression here in the interface, and I can modify it. For example, we can say, okay, this time maybe it's not 2, but it's 4 times spiral rotation. And now we do not select the Y rotation, but we select this Y spiral rotation and hit apply. And you can see now that the rotation is way too much, so 4 was maybe a bit too much. Let's set this to 0.5. Apply. And this already looks better. And now let's take a look at a quick RAM preview. What you can see is it is still quite strong, and also it's going to the wrong direction. Yeah, I want to rotate it in exactly the opposite direction, not in this one, but in the opposite one. Therefore, I just say -0.5 and reapply. And now you can see it rotates in the opposite direction, and maybe this is still a bit much. So maybe it's better to say 0.25 and reapply. And now the result looks as follows. So you can see it nicely swings with the movement and has this elastically moving tail. Currently we've only animated here the Y rotation, so the movement in X. We could also, of course, in the same way animate the X rotation here that is currently set to -5. If we set this to 5, it rotates here on the upper half, and of course we can also make it swing up and down according to the up and down movement by linking not to the position X but to the position Y and apply to this property here. But there's even more that you can do with these spiral rotation properties. One idea is to use the pendulum I expression. The pendulum I expression makes elements swing. Yeah? And one thing that you can, of course, make swing here is this tail, and if you set the decay to 0, it will swing infinitely without ever stopping. So this would look as follows. Again, you have here a comparison to the original. Yeah, this is with the stiff tail, and this is with the pendulum I expression applied to the tail, and you can see that it constantly rotates and swings in a very organic and nice way and adds a little bit more life to this element. So to do this, we would need to override the simple link 1D I expression that we've applied to the spiral rotation before. But since I want to save this for later reuse, I do a little trick and create a new slider by going to Effect, Expression Controls, Slider Control, and I rename this slider to Simple Link. That is just the name for it. And then I go to the spiral rotation with the I expression, go with the I expressions tool on load, which means I have now effectively copied the expression from here to the I expressions interface. And then I look for this slider, simple link, and apply it. So now we have this simple link I expression sitting here on the slider that effectively does nothing, but this allows us to reuse it later, as you will see in a moment. Now we are ready to override this one here with the pendulum I expression. For this we go to the library, choose in the physics simulation tab, or we can also look for pendulum and find it here under physics simulations real-time pendulum. Click OK. And now a start angle of 90 is way too much, because it would mean each tail element here rotates by 90. So we set this rather to a small rotation like this 5 here, that we have here currently applied. The speed is maybe also a bit much. Let's set this to 6. And the decay to 0, because this means it should never stop swinging. Otherwise, it gets slower over time and stops swinging. If we apply this, you can see now the tail immediately changes, and now let's look at a ramp preview. As you can see, the tail now nicely swings left and right like a pendulum, and you can do even more than that. Of course, you can adjust now the speed of the pendulum and so on. But another thing you can do is to have a pendulum motion that is not only swinging left-right, but that is swinging in a circle. And for this, we also need to apply the same not only to the Y rotation, but also to the X rotation. So let's do this. And look how it's looking like now. As you can see, now the pendulum does not swing left-right, but it swings on the diagonal like this. This is not yet exactly what we want. And the trick that we now in addition need to apply, so if you have the same pendulum on X and Y, it will swing in a diagonal way. But if you now let the simulations start a little bit delayed, then it will change. So let's say this simulation here, the X1 should start at, say, frame number 1. Apply. And now let's say the second one should be so the spiral Y rotation should be applied 6 frames later. Apply this. And now let's look again at a ramp preview. And as by magic, you can see that now the tail is swinging in a rotating fashion. So we've seen now two alternatives what we can do with the tail. Either we let it rotate using the pendulum I expression, or we let it deform according to the movement with the simple link. And now the question is, can we have the best of both of these worlds? And the answer is yes, we can. What we use for this is the average link I expression. An average link takes two inputs, in this case our simple link I expression and the pendulum I expression, and generates one output of it that it applies to our spiral rotation. You also have a balance parameter which you can control which of the two inputs has how much influence. This means that the simple link 1D here has 20% influence and the second link, namely the pendulum, has 80%. What happens is then the following. Remember that our simple link nicely reacted to the movement. The tail nicely reacted to the movement, but it had no pendulum swinging. Whereas the pendulum I expression caused this nice rotation here, but it was not able to make the tail react on the actual movement. Now the average link combines both these elements and gets a really realistic movement that both reacts on the movement of the Hypno and also involves this constant rotation. You might now wonder how you can apply more than one expression to such a property. So if we apply the average link to the spiral rotation, which properties do we apply the pendulum and the 1D link to? Well, we have already before parked the simple link here on a slider, and we can do exactly the same also with the pendulum. Here is how it works. We select our spiral rotation that we applied the pendulum I expression to and load it into the I expression interface. Now we can close this effect temporarily here and create another slider by going to Effect, Expression Controls, Slider Control. This slider we rename to Pendulum, and we apply to it our I expression. Apply. Together with the slider control that we created before, we have now our simple link slider and our pendulum slider. We go to the library and select from the linking bundle the average link 1D I expression. Again, 1D because it's a 1D property. Yeah? So it consists of just one number and not several of them. And now this average link has two inputs. The first input we link to the slider of the simple link by just clicking here, and the second slider we link to the pendulum. Now we have an I expression that combines the best of both of them, so it always takes their average. And this is again something that we apply now finally to this spiral rotation of the Hypno. Apply. So as you can see, now the Hypno is nicely rotating its tail, and also it is reacting, so the tail is reacting on the movement, so it turns in the direction of the movement. And maybe this is at the moment that's not so strongly visible, this reaction, so maybe we change this balance here to another value, but I leave this up to you. Also, of course, if you want to have up-down movement, exactly the same reaction also on the spiral rotation X, you need to apply such a construct here, but I leave this up to you. And let's better recap now what we've learned. We've seen that with the simple link 1D, you can link the rotation to the speed of the position, which effectively lets turn the element according to its movement. The same idea can also be used to realistically turn and deform the tail according to the movement. Alternatively, the tail can be animated using a pendulum I expression, which yields such a swinging behavior. Finally, both alternatives can be combined by parking each of the two I expressions on an individual slider and then applying an average link to the result. And finally, if you need more information about I expressions, visit marmoworld.com and click in the menu on I expressions. And here you find a comprehensive documentation of all the 85 I expressions that are currently available, and you can buy a license for either the full tool or for each of these bundles here separately. So in this tutorial we used from the linking bundle some expressions, these different link expressions, and also from the physics simulation bundle this pendulum I expression. Further down, you also find here a lot of links to other tutorials that use I expressions and help you to learn even more about this great tool. Okay, that's it from my side. I hope you enjoyed this tutorial and are again with me next time.
Wow, that was great. Thanks so much, Matthias, and thank you for watching. Hope you enjoyed it, and we'll see you soon.